Chapter 12, we cover simple interest. So we've jumped ahead for test 3 and we did compounding interest, where the interest goes into the account and then earns more interest, which is what makes it compound. Simple interest is not that. So simple interest is just we're either going to pay the interest at the beginning of the loan or at the end of the loan, and it's just a straight computation using a formula. So our formula is interest equals principal times rate times time, which is I equals PRT. So then you want to just recognize that we calculate that interest and our time is always in terms of years. So if the problem gives it to us in years, then obviously the T is just however many years it is. But more often, it's going to give it to us in times that's less than a year. So it could be given to us monthly, like they borrow for 3 months. Then that time is going to be 3 over 12 because it's 3 months out of 12 months, again, because it's in terms of a year. Or it'll be daily. And normally what this book uses is what's called ordinary interest or banker's interest, and that uses 360 days. That's a simplified method to say, well, what if we just had 30 days in every month? We do not. That's not how our months are. But that simplified method, just making it like that, would be what ordinary interest is doing. Really what we have is 365 days in a year. That's exact interest. So, but the only time we use 365 is when we see the word exact. So by far, the majority of these questions are going to be, if we're talking in terms of days, it's going to be ordinary interest, and we put the number of days over 360. But we'll first have to figure out how many days it is, because as we read these business problems, it'll be like, the corporation borrows money on September 12th and it's due back on December 15th. So how much interest do they owe? Well, you've got to first figure out, okay, well, how many days is there between September 12th and December 15th? And the easiest way to do it is to let your calculator do it and use that date function. So the date function, again, it's in our second menu and it's above the number 1. So I'm hoping that you guys already used this in the last test material so that you know how to do it. But you'll definitely have to use it in these problems because, again, like I said, they will be borrowing money for over a decent amount of time in terms of days, and it's harder to add those up and not be a day off. So let the calculator do that work for you. Once you go into that date function in your calculator, you have these 3 fields. So you're going to type in, if it was like what I said, September 12th to December 15th, your September 12th is going to go in date 1, and then your December 15th is going to go in date 2, and then your DBD stands for your days between your dates. You would compute that. So you just have to make sure you're entering those in the right format. So the calculator is preset to December 31st, 1990. So that's what I'm showing you here. So that's what we're looking at. That would really be entered 12.3190, and it's going to pop up. But say we wanted to put in a different date, February 18th, 2003, you would put in 2. The decimal is separating the month from the days, a 2-digit day, so 18, and then a 2-digit year. Don't enter that 4-digit year, and then just make sure that you put that decimal between your month and your days. And then you would compute your days between the dates. Now, there could be problems where they say, okay, this company gets a loan on September 12th, and it's a 90-day loan. When is it due? If you have one like that, you would put in your September 12th in date 1. You would arrow past your date 2. Go down to your days between your dates, put in 90, and then push enter. Arrow back up to date 2, and then compute that. So it depends on what the problem's asking for, but you can play around with that date function. Okay, then the next thing that we get into is our maturity value, because the I equals PRT formula, interest equals principal times rate times time, just calculates the interest. What if you want to know the maturity value? So the maturity value, if you look at that formula, it's your principal plus your interest. So if I go and get a CD at a bank, give them $1,000 for a 6-month CD, and they pay me so much interest, when I come back to cash in that CD, I want my $1,000 back. I don't just want the interest. So that's what that maturity value is saying, is you're going to get your $1,000 back plus the interest. And then this formula here is the kind of the bigger version. A lot of times when I read a problem, I'll first start with my interest. So I can calculate my interest. It's principal times rate times time. Then if they want the maturity value, all I got to do is add the principal back to that. But there's sometimes in some problems where we're going to be looking for the principal, in which case you have to revert back to this big formula here because you don't have the principal, so you can't calculate the interest. And then obviously if you don't have the principal, you can't just calculate that. You can't directly just add them to get to the maturity value. So you'll have to go back to this big formula, fill in what you do know, which would be the maturity value, the rate, and the time, and then solve. And then what I tell you here is I personally don't rearrange the formulas. I always leave them like this. The maturity value is principal plus interest, which is principal times rate times time. And then my interest is principal times rate times time. Whoops, let me go back, sorry. Where like the textbook, and if you're going to use the help aids in the My Math Lab, which I know a lot of people do, they do rearrange the formula. So say you're looking for your time, they're going to have the t on the one side and that set that equal to I divided by PRT or PR divided by I. And I never rearrange those. I always just stick to the same formula and then fill in what I know and solve for whatever that missing variable is. But whatever is easier for you to do. So then that's going to be these two chapters, this chapter, getting comfortable with calculating our interest, and then now adding that interest to the principal to get back to the maturity value, possibly finding the principal if they give us the maturity value, the rate and the time.